I hit with child B, moving in the opposite direction. Nice. So head on collision. So the one's going this way, one's going that way, opposite direction, boom. After the collision, okay, so let's draw the picture here. Right, so here is the bad child, and here's the good child. Okay, what is the mass of child here? That is 42.3 kilograms, and the other one is, what's the other one? 50.5 kilograms. Now, before the collision, this guy is going right with 6, and this guy is going left with 2.6. After the collision, child A, this is A, this is B, continues to move at a speed of 0.55. So after the collision, child A is still going forward here with 0.55. What's child B doing? Well, child B has to be going to the right, unless child B passed through A, which it didn't. So we'll call this X. And the question's going to be, what's the X, I'm sure. What's the speed of child B after the collision? Alright, so this is what type of problem? Yeah, it's M1, U1, so that and that time. Oh, no, I have to be very careful here. It's minus 2.6 because it's left times 50.5 equals 0.55 times 42.3 plus 50.5 times x. And that's it. We just have to solve this for x. So let's see what we get. 42.3 times 6 minus 2.6 times 50.5 minus 0.55 times 42.3 divided by 50.5. So before I type it in, what would be a reasonable answer if you could use your imagination for x? So A is going quite fast. It's going like more than twice as fast as B. And they're kind of similar in mass, although B is a little bit bigger. And A is not going that fast after the collision. So kind of feels like A might have given B a good push in the other direction. So could we estimate a number here? I don't know, like 10, somewhere in the scale of 10 is what I would just guess. I don't think x will be small, right? It's not going to be like 0.6. That kind of seems wrong, doesn't it? It can't be negative because it's going the wrong way. It can't be too big, but it'll be big enough. So I think 10 maybe. Let's see what we get. Okay, I was way off with my 10. 1.97. So the child is going much slower than how I pictured this collision. I think I pictured it quite dramatically. 1.97 meters per second. Now the question said the speed, so they don't actually care about the direction, but it's a positive, so it's to the right. But because they said speed, they don't care. How many marks for this? Did you see how many marks?
4.
It's 4. Now think about it. 4 marks for this to this, you know? So here's my confession. Every year I'm always saddened and confused by why students do so not great in the physics exam. Especially when I go through the questions and everybody's like, yes, these are easy and they're okay and I will be great and everything will be wonderful. I'm like, yeah. I can't understand why you score better in chemistry than in physics, students. I can't. Yeah, but it doesn't feel like that, does it? Right? Are you sitting in class going, man, this is so much easier than physics? No. Maybe you are. No, okay. So like, I don't know what goes wrong in the exam. The only thing I can think of is that students don't practice enough because they think they can do it because it looks easy. Okay. Well, some of them do. Perhaps. So look, anyways, have we finished all the mechanics in section A? We have, but there's mechanics in section B. Anyways, we can do that next week. We'll go back to finishing the book, and then next week we'll continue with this exemplar exam. My tip to you is, these questions I did today, maybe you want to try see if you can do them at home, because you'll have the videos later this evening to check your work. My tip anyways.